Hey guys, Mr. Ray here with our next lesson in grade 10 academic math in the quadratics unit. So the last few lessons we've been working a lot with the vertex form. Basically, we created the vertex form by looking at possible transformations using parameters a, h, and k, and that created the vertex form, which very nicely gave us the vertex very directly. That's why we call it the vertex form. We started with the standard form, which is the y equals ax squared plus bx plus c. And then we spent about 3 lessons on vertex form. And the last lesson we looked at factored form. Okay, so we've got 3 different forms that we can write a quadratic equation in. Each of them have their own benefits. So if I go back to the definitions here, in standard form, which is written that way, doesn't give you a whole lot, but actually the c value, that's the y-intercept. So if you're just given standard form, you can get the y-intercept very directly, and we just do that by plugging in x equals 0, and we get y equals c if we plug in 0 for x. Then we looked at the vertex form, and it's written, there's our template for it, and the vertex can be found by it's the coordinates hk from the equation. And then most recently we looked at factored form. So if the equation is written in this form, we can get the x-intercepts, which are r and s. So between the 3 of these forms, we can get all of the important information. We can get vertex, x-intercepts, and y-intercept. The most important, all the important points we can get. So now we're not going to be given questions where we're given all 3 forms. That would be too much to ask for. So we'll get the question in one of 3 forms, and what we'd like to do is be able to convert from the given form to the other 2 forms. Okay, so this little diagram here, you can see it's kind of built on a triangle. At the tips of each triangle, I've got the forms. So I've got standard form here, vertex form in the left corner, and factored form here. So the arrows in between are the processes we use to start with one form to create the other form. Okay, so for example, vertex form, if I want to create standard form, it's just a matter of expanding. So expand the brackets and simplify the terms, and that creates standard form. If we had standard form and we wanted vertex form, we just recently did a lesson in this. This is where we complete the square and we can get vertex form. If we have our equation in standard form and we want to create factored form, well, this is where our previous unit work will come in. We have to factor the quadratic to come up with the factored form. So you'll have to revive those skills from a few weeks back. And if you want to go the other way, if you're given factored form, you just expand. You do like your FOIL here, add the like terms, and you get standard form. Now you can see down at the bottom here, I've got this arrow between vertex and factored with this double line across. That's basically saying there's no direct way to get one of these forms from the other. So there's no process. So does that mean we can't do it? No, it just means we have to do it in 2 steps. For example, if I'm given vertex form and I want factored form, I first have to create standard form by expanding, and then once I have standard form, I factor to get factored form. If I want to go the other direction, if we're given factored form and we want vertex form, well, first we're going to expand to get standard form, and then we're going to complete the square to get vertex form. So standard form is always kind of the intermediate form that we can use to get the other 2 forms. Okay, so I got some examples here just to practice. Okay, so there's going to be one of each. So the first one is if we were given an equation in standard form, let's create the other two forms, vertex and factored form. Okay, so now remember, standard form, I can go directly to either one of these, to vertex form or factored form. So I could do either one of these first. It doesn't really matter. So the first thing we're going to do is let's do factored form. Okay, so I'm going to start with the original equation, y equals x squared minus 8x minus 20. Okay, now we're going to factor this. So this is where this would be a simple trinomial factoring. And the two numbers that we're looking for go inside the brackets. They're going to multiply to negative 20, and they're going to add to negative 8. So you could do the chart and work your way through it, or if you think of the numbers, well, you can think the numbers would be negative 10 and positive 2. That satisfies that, so we can just put them directly in. So negative 10, positive 2. So there's the equation of factored form. So so far we've got standard form and factored form. Let's create the vertex form. Okay, so if you remember, the first thing we do is you put the first two terms in brackets, so I'll go right to that step since it's not too hard to see what we're doing. So x squared minus 8x in brackets, minus 20 outside. Okay, then what we do, we didn't have to factor anything out, so we go right to creating the third term inside the brackets. That makes it a perfect square trinomial. So remember, it's half of the negative 8 squared. So half of that is negative 4. If we square negative 4, we get positive 16. So 16 is the number I'm going to add and then subtract to keep it balanced. Okay, now we're just going to take the negative 16 outside, which is fine because there's nothing out front to multiply with. It's just a 1. So I'll send that negative 16 outside. And then the last step is converting the perfect square trinomial into a binomial squared. And remember, the second term of the binomial is half of the coefficient of x, so that's minus 4. And then combining these, we get a minus 36. Okay. How can I check this? Well, I mean, I could go back and forth and see my algebra work, see if it's right, but you might be just making the same mistake over and over. So the best way to check this is to go into a graphing software like Desmos, enter all three of these equations as separate equations, and if the graphs all overlap, if they're all the same graph, which is easy to see because it's just one single graph, you know you've got all three of them right. Okay, so that's the best way to check if you're doing this. Obviously, you can't do that on a test, but if you're doing homework or an assignment, you can do that. Okay, next example. This time we're starting from vertex form. So if I want to create standard form and factor form, I really have no choice but to do the standard form first, because like we said on the chart, I can't go directly from vertex form to factored form. I have to get standard form first. So that's what we'll do. So standard form. All right. So standard form, anytime we create standard form from the other two, we're just expanding. So instead of writing it out as x minus 1 squared, I just want to remind you that x minus 1 squared means x minus 1 times x minus 1. So you avoid the temptation of just putting that as x squared plus 1, which it's not. So now we can actually expand this out. So I've got x squared, I've got a negative x, another negative x, and then a plus 1, and then the minus 25. I don't have to put brackets around this because it's just whatever this is I can combine with the negative 25. So I can finish up in this one step. So x squared, so I've just got the 1, I've got 2 negative x's. So that's negative 2x. A plus 1 and a minus 25 work out to be minus 24. So there's the standard form. Okay, now we could do the factored form. And again, I would have had to have done standard form first to do factored form. Okay, so now I'm starting with what I had here. So y equals x squared minus 2x minus 24. And again, just like above, this is a simple trinomial factoring. So I can immediately write this as binomial squared thinking vertex form. I can write this as 2 binomial factors, both starting with x, and those two numbers multiply to negative 24 and they add to negative 2. So if you can think of them, you can just plop them in right away, and I'm thinking it's going to be negative 6 and positive 4. Negative 6 times positive 4 is negative 24. Negative 6 plus 4 is negative 2. And we're done. Okay, so now that we've got the hang of this a little bit, I didn't ask this question, but what information can I now get about this quadratic? Well, from the original part, I know that the vertex is 1 comma negative 25. Okay, I know from standard form that the y-intercept is negative 24. And I know from factored form that the x-intercepts are positive 6 and negative 4. So just by doing this conversion process, I've got all the information I could want, pretty much, from this quadratic relation. And that's why it's important to be able to do this conversion, is to get information that's not readily available. Okay, so let's do the last one here. This time we're starting from factored form. So we want standard and vertex, and I have to get standard first because I can't go directly from factored to vertex. Okay, so we'll write it out. Y equals 2, x minus 5, x plus 9. Okay, so remember, every time we go to standard form, we're just expanding. So we're doing our FOIL in the brackets, and then whatever we get there, we multiply everything by 2. So I keep my brackets, and I've got an x squared, I've got a plus 9x minus 5x minus 45. Okay, and don't forget, before you multiply by 2, you simplify what's inside. So that's going to turn into plus 4x minus 45, and now we can multiply each of those 3 terms by 2. So we get 2x squared plus 8x minus 90. Okay, that's the standard form. So I just figured out that the y-intercept is negative 90. I already knew that the x-intercepts were 5 and negative 9. And now I'm going to figure out what the vertex is. Okay, so I'm going to start with the standard form. I'll put the brackets around as my first line. Brackets around just the first 2 terms. Then we're going to factor out the 2 because that's the coefficient of x squared. So I get 2 bracket x squared plus 4x minus 90. Now we're going to complete the square inside. So half of 4 is 2, 2 squared is 4. So we're going to add and subtract 4 inside the brackets. Okay, now I'm going to take out the negative 4 outside. And when I do that, I have to multiply it first by 2. So let's just write, we'll keep the 4 inside, send the negative 4 outside, but we have to multiply by 2. So that's the minus 90 and then minus 8. And then the last line is just converting that back to a binomial squared. And we know it's x, and we know it's half of positive 4. And then we combine those two together to get negative 98. And now we just discovered there's the vertex form, and we now know that the vertex is coordinates -2, -98. Okay, so this is a very important skill. Now that we've been working with all three forms separately, now we can go and create the other two forms by this process. So there is an assignment based on this, basically filling in, showing me how to create the other two forms given one of the forms. Definitely have to show me your work. It's not enough just to write down the final answer. I want to see how you got to it. So that will be a good test of basically the last couple of lessons. You're going to be practicing expanding. You're going to be practicing completing the square. You're going to be practicing factoring. So those are very important skills, and you're going to need those for each question in this assignment. Okay, so that's it for today. I'll see you on the next lesson.